Here's a concept that we're bringing forward from when we talked about atoms. We said that for atoms, and as it turns out for anything, we can have what we call a molar mass. It is the mass of 1 mole. So units for molar mass are going to be grams of that substance to 1 mole of that substance. Okay, molar mass. And I'll just kind of remind you, if you have a periodic table handy, what is the molar mass for carbon? Molar mass for carbon. You should know this. Use a periodic table. The molar mass for carbon is 12.01 grams of carbon per 1 mole of carbon. 1 mole of carbon atoms. Remember how that goes? Molar mass. And we can use molar mass like this, or we can flip it depending upon what we need to cancel. It's like a physical constant of that element. Okay? So we can talk about molar masses for atoms like that, or we can talk about molar masses for molecules, the grams you need to set aside to get 1 mole of molecules, molar mass for formula units, the grams you need to set aside to get 1 mole of repeating formula units. So as I said, units for molar mass are grams per mole. This is kind of what I call the linear version. This is the unpacked version. Just G/mol, grams per mole. This actually is my favorite way if you're using the molar mass as a conversion factor. Remember, I call molar masses MMs. This so your units can cancel and all that. This is an alternative way of showing grams per mole. The way this works is if you see anything, in this case moles, anything raised to a negative power, that means it's in the denominator. So this unpacked is moles raised to the first power. See how that works? Yeah, those all mean the same thing. So molar mass. We said the molar mass for the elements is the same thing as the decimal number for that element, or the atomic weight. That's the molar mass for the element, for an atom. The molar mass for molecules, the molar mass for molecules is something that we recently calculated in this class. When you calculated the molecular weight, that is also the molar mass for that compound. We said if it's an ionic compound, instead of a molecular weight, we calculate a formula weight. If you calculate a formula weight, that is the molar mass for that ionic compound. Okay? Molar mass, the mass you need to set aside to get 1 mole of those formula units. So this is just a kind of, this would apply to earlier when we did molar mass for atoms, and it also applies now for molar mass for molecules and formula units. Units of molar mass are grams per mole, and units of the atomic weight of an individual atom, or the molecular weight of a molecule, or the weight of a repeating unit, a formula unit, those have units of what? Those are in units of AMUs. So just like what we did with the decimal number, to go back and forth between, like, carbon has an average atomic weight of 12.01, carbon's molar mass, 12.01 AMUs, 12.01 AMUs is how much on average a carbon atom weighs. Then we said its molar mass is 12.01 grams of carbon per 1 mole of carbon atoms. So it's the same number, you just have to change the units. This is also a repeat slide. Since anytime you have I'll underline conversion factor here, but anytime you have a constant, like the units of the constant, like grams per mole, the units tell you what you can go back and forth between. We can go from grams to moles, or moles to grams. You know, we might have to flip it, but we can do both of those with the molar mass of substance. So let's do an example, and it looks sort of like this. Now to me, oh, I see. This example actually isn't having us use it as a conversion factor. This example, we're just supposed to knock out the molar mass for these compounds. The ethane actually then is a covalent or molecular compound, And I know it looks like there are no metals in ammonium chloride, but this is one of those exceptions. Ammonium is an ion. That's that NH4 plus 1 that we've been learning this unit of material. So this actually is an ionic compound. CPD, and there are no metals up here, so this is a molecular compound, which has nothing to do with what the question's asking. The question is asking what is the molar mass, or MM, of these compounds. Now, what I would suggest doing is kind of thinking of it stepwise. I don't know if I do or not. First off, you come up with the molecular weight, or the formula weight. Okay, and of course those units are going to be AMUs, and then you take that number and you switch the units from AMUs to grams per mole. And voila, you have the molar mass. So let's take a look at, for ethane, what this looks like. Now, I know this is going to look really like, are you serious? I have to do that sort of problem. I'm going to show you what I call the explicit way to work it, and then I'm going to show you a shortcut. So you can jot this down and all this, but it does get easier, okay? So if we consider 1 mole of C2H6 molecules, we have 2 moles of carbon atoms in that blob of 1 mole of those molecules. We have 2 moles of carbon, and we have 2 moles of hydrogen atoms. Of course, can you see where this 2 came from the subscript, okay, and this 6 came from the subscript. So with that in mind, we can go ahead and come up with a molar mass like this. We have, just like I said, we have 2 moles of carbon atoms in 1 mole of the compound, and the molar mass for carbon from the periodic table is 12.01 grams per 1 mole. So moles of carbon cancel, we're left with grams per mole of C2H6 with regard to carbon. We need to do a similar thing for hydrogen. Like I said, there are 6 moles of hydrogen in that per 1 mole of compound. That came from the subscript 6 here. From the periodic table, we know that there's 1.008 grams of hydrogen in 1 mole of hydrogen. So now our moles of hydrogen cancel. We're left with grams, in this case, relative to hydrogen, per mole of C2H6. Now if we multiply and then add, okay, rounded to 2 significant figures, you get a mass of 30.07, and the units would be grams per 1 mole of compound. Now that's the explicit way to work it. I think you're going to like this other way. Okay, this is the abbreviated way, and this is the way I would do it. Now I'm all about units, but when you're doing a molar mass calculation, I'm fine if you just blow off the units, so to speak. So can you see where this represents the carbon? 2 times 12.01, and this represents the hydrogen, 6 times 1.008. Of course, those decimal numbers are from the periodic table. Those whole numbers are from the formula. And then when I crunch that through my calculator, I get the value again, 30.07, rounded to 2 decimals. And now this is where I need to make sure I keep my wits about me. I'm after molar mass, which is grams per mole. So I hope that works for you. Just one more thing before I leave this is that if you have to go ahead and use this in a calculation, I would actually, what we say, unpack that, and it would be 30.07 grams per 1 mole. Okay, specifically grams of C2H6 per 1 mole of C2H6 molecules. So I hope that works for you. Let's go ahead and take a look at that ionic compound, that ammonium chloride. And I'm going to, if it's okay with you, which I bet it is, I'm going to go ahead and use the abbreviated approach. So it looks like this. I need to account for the nitrogen. The decimal number for nitrogen is 14.01. There's 1 of them because that's the subscript for nitrogen. There are 4 hydrogens. The decimal number for hydrogen is 1.008. Then I need to finish up with my chlorine. There's 1 chlorine. The decimal number is 35.45. Round to 2 decimals, okay? Notice I come up with 53.49, and that is the molar mass. That actually is also the formula weight. But units of formula weight are AMUs. Units of molar mass are grams per mole. Right? Okay, oops, I couldn't decide whether I went on or not. So I've been kind of telling you just round to 2 decimals in the last 2 examples of the molar mass of ethane and then ammonium chloride round to 2 decimals. You're like, are you sure about that? And the way it works is, if in your problem you come up with a molar mass of something that is more than 10 grams per mole, you're probably going to have something that has 2 decimal places in the decimal number from the periodic table. And in that case, you need to only allow 2 decimal places in your answer. If you're working with something that's light, less than 10 grams per mole, its molar mass, then you should be using 3 decimal places. Okay, so I'm hoping I'm going to show you some examples so that all kind of works. So I have in my notes that this is the assignment, and I'm not sure. Be sure to check the assignment, well, you know where you go to get your assignments, and see if I've posted this or not.